unraveling uncertainty, exploring probability distributions and their marginal mysteries in real world applications. Introduction to probability. In this presentation, we will delve into the fascinating world of probability distributions. Understanding these concepts helps us to navigate the uncertainties of real life. We will explore their marginal mysteries and how they apply to various fields. Understanding probability distributions. Probability distributions are mathematical functions that describe the likelihood of different outcomes. They can be discrete or continuous, each serving unique purposes. By unraveling these distributions, we gain insights into the uncertainty surrounding real-world phenomena. The role of marginal distributions. Marginal distributions provide a way to examine the probability of a single variable, ignoring others. This helps simplify complex problems and focus on key variables. Understanding these distributions is crucial for making informed decisions in uncertain environments. Real-world applications. Probability distributions are used in various fields, such as finance, engineering, and healthcare. For instance, they help in risk assessment, predicting stock prices, and modeling disease spread. These applications highlight the practical importance. Challenges in interpretation. Interpreting probability distributions can be challenging due to the complexity of data. Misunderstandings can lead to incorrect conclusions. It's essential to approach these distributions with a critical mindset to accurately assess the implications of conclusion. Embracing uncertainty. As we conclude, remember that uncertainty is an integral part of decision making. By unraveling probability distributions and their marginal mysteries, we equip ourselves to better navigate the complexities of the world. Embrace uncertainty.
Hello everyone. Today I am here to explain about the C program to identify to conclude the concept about the joint probability distribution and marginal distribution and its mean variance, standard deviation, and covariance. Here we first declare the header files has include stdio.h and has include math.h, and here we define the maximum size 100, and here is the main function starts. Int x, declare the x and y points, and we enter the value of x and enter the value of y. Here we check the num size is greater than maximum size, num y is greater than maximum size. If the maximum size is and num max is greater than maximum size, it is the error value prints, and here we declare the double of x and y, and input for the x, enter the values for x, and here is the enter the values for y, and here is the input for the joint probabilities, and here we calculate the marginal distribution, and calculate the here we calculate the e of x and e of y, and next calculate the e of xy, and calculate the covariance of x comma y, and here is the calculate the variance and standard deviation for the joint probability, and here we calculate the correlation coefficients rho for the joint probability distribution. Here we display the joint probability distribution table. Next we display about the marginal distribution table for using the while loops and others, and here we display them all calculations, all calculations like e of x, e of y, e of xy, covariance of xy, sigma x square, sigma y square, sigma x, sigma y, and correlation coefficients rho of xy for the given probability function. When I execute this, it takes inputs for enter the value of x, values for x. I entered 2, and it tells enter the number of values for y. I enter 4, and next enter the values for x, and it using the floating numbers. X of 0 I entered 1, and x of 1 I entered 2, and enter the values for x. Y of 0 I entered -2, and y of 1 is I entered -1, and y of 2 is 4, and y of 3 is 5. and enter the joint probabilities for each x and y pairs. P of x is equal to 1, y is equal to minus 2. I entered 0.1 and P of x is equal to 1, y is equal to minus 2. I entered 0.2 and P of x is equal to 1 and y is equal to 4. I entered 0 and P of x is equal to 1, y is equal to 5. I entered 0.3. And next it takes the P of x is equal to 2 and y is equal to minus 2. I entered 0.2 and P of x is equal to 2 and y is equal to minus 1. I entered 0.1 and P of x is equal to 2, y is equal to 4. I entered 0.1 and P of x is equal to 2, y is equal to 5. I entered 0 and entered it gives joint probability distribution table. Joint distribution table as a x is equal to 1, y is equal to x is equal to 1, x is equal to 2, and y is equal to minus 2, y is equal to minus 1, y is equal to 4, y is equal to 5. It gives the x is equal to 1, y is equal to minus 2 as a 0.1, x is equal to 1, y is equal to minus 1 as a 0.2, x is equal to 1, y is equal to 4 as the 0.4, x is equal to 1, y is equal to 5 as the 0.3, and x is equal to 2, y is equal to minus 2 as a 2 0.2, x is equal to 2, y is equal to minus 2 minus 1 as a 0.1, x is equal to 2, y is equal to 4 as the 0.1, x is equal to 2, y is equal to 5 as the 0.0, and a marginal distribution